are going to discuss flowcharts or flow diagrams as one of the subtopics covered under numerical methods. If one has a challenge or a problem, as you know that you always have challenges, and especially in mathematics, all challenges, we call them problems. He or she writes down steps. These steps that are needed to solve it. So the steps needed to solve a challenge, especially in mathematics, and these steps are called an algorithm. So if you have a set of steps which have been written down to solve a challenge or a problem, then that is an algorithm. Therefore, we define an algorithm as a detailed sequence. A detailed sequence of steps which are needed or required to solve a problem. These steps can be represented in a diagrammatic form, and this diagram we shall call it a flow chart. So a flow chart is a diagram that shows a detailed sequence of steps which are joined to solve a problem or a challenge, and these steps we call them an algorithm. So that's a simple way of defining an algorithm as a list of steps which are required to solve a problem. A flow chart that is the one that shows how logical sequence of steps that must be followed in order to solve a problem. And we have got categories of flow charts. Flow charts, we have simple ones, like if a student has a set of rules or steps that enables him or her to wake up in the morning systematically to go to prep, it can be written in the form of flow chart, and that would be a simple one. For instance, if is to start, and start maybe that is waking up. You wake up, that is starting his own program. Then you wash face, that is when you don't say prayer. Wash face, after washing you put on, dress up. Then after dressing up you pick books, then go to prep, then you stop. That means this can be a simple flow chart. Start, you wash face, dress up, pick books, go to prep, then the flow chart stops or your program ends. So every flow chart must have a beginning and end point. That's the simple flow chart. Then you have a looped flow chart. When you talk of a looped flow chart, then it is whereby you draw a flow chart and some steps are repeated. Where it's when you find a question that is n equal to 6, let's take an example, is the number of times equal to 6, and possibly you began with n equal to 1, it means this n will always be increased, and you keep on repeating it until you get n as 6. That's a looped flow chart. Then finally we have a branched flow chart. Shall we see these flow charts? Branched flow chart. This one has a branch, especially on a decision, and you make just one decision Therefore, after making a decision, you don't repeat, you continue and finish the program. So we shall look at these categories of flowcharts. Now, when we talk of an algorithm, we said it is a set of procedures or steps to follow. We want to take an example of an algorithm, and this example we can see the steps which one goes through to solve a quadratic equation. You can have an equation of the form ax squared plus bx plus equal to 0. Now, if you have solved this question, you can have a set of procedures that is to start on the question. You read that question. Now, after reading this question, you have to read the coefficients. You start on the question, read the coefficients. Coefficients, we have A, we have B, we have C. After reading these coefficients, then you want to use a bulldozer. The formula, substitute any formula of x, which is equal to minus b plus or minus root b squared minus 4ac all over 2a. This is the formula where a, b, c are substituted. Then you will command the program or to print or to write values of x, x1, then x2. Then the computer will give you or the calculator will give you these values. Then the program stops. So this is an example of an algorithm. Steps that are clearly written down to solve a problem. Like you want to solve a quadratic equation, so this is a procedure, and we call it an algorithm. Now, I want to look at another example of an algorithm. Like if you want to solve an equation, especially under numerical methods, we have to, for instance, you want to use Newton-Raphson method. Now, here, when you have a question, then you start on the question, then you look at the first approximation as first approximation. But when you start with n equal to 0 because the formula we have the subscript n. Then you read the first approximation. It is substituting the formula, which is an iterative formula based on NRM, which is xn plus 1 as xn minus f xn over f prime xn. So this is an NRM formula whereby x naught is substituted and shall have x1 as x naught minus f of x naught divided by f prime of x naught. Meaning that the program you solve, you get x1. Then you have to test whether x1 minus x naught is less than error or tolerance. Is. Now, if the difference is less, then you stop. If the difference is still greater, you repeat, and therefore that will be a looped flowchart. So you repeat, increase n by 1, then use this one is substituted by xn plus 1. We shall explain what these ones mean. And if the difference is less, then you print the root. It can be xn plus 1, then you stop the program. So these are the steps, and we call this an algorithm. Based on NRM, use start, read the formula, substitute, you test, repeat. If the difference is greater, the difference it becomes less, print the root, then you stop. In order to get a flowchart in this video, we are going to look at the symbols or figures which are used to form a clear flowchart. We want to begin with flow lines. Flow lines. When we are making a flowchart, we need lines either moving horizontally or vertically, connecting symbols or figure from the other. So these are connecting lines. They connect one figure to the other and show clearly the order of operation. Then we have start. We say start or begin, or end, stroke, stop, symbol. And this one is overflow. So it can either be like this, start is written here, start, or if you want to end, because it is from above and you end or stop the program. So it is oval shape. This oval shape, when you want to start the program, you use this shape. If you want to end the program, you use the same shape. And these are the connecting lines we talked about. So these are the first two, and we also have what you call the the read statement. Read statement. Now, if you want to read or input the program, then you use the symbol and we call it a parallelogram. You want command maybe the computer to read something, then your program should be drawn in a flowchart using this symbol, and we call it a parallelogram. Parallelogram shape. This one is for read. So you say read, and assume you want to read A, you say read A. And we can even use the same figure to print or to write. You can say, if you want command, maybe the computer to print for you, say print, and you have a designed program. This is where you say print maybe xn, then as you stop or as you continue depending on the program. So we have read statement or print statement. We use parallelogram as the best shape to input those two words. It indicates the process of inputting. So this indicates the process of inputting or outputting data, as in entering data or displaying results. Next we have assignment box, which is a very important assignment box. It is also important, which is in the form of a rectangle. Like previously we said, we wrote down the process or the steps to solve a problem. Like you have the formula b squared minus 4ac. This is, we call it a discriminant. We rewrite it in assignment box, or what you want to solve or what you want to do, the task you are given is written in this box. Like those who know the Raphson method, then the formula xn as xn minus fxn over f prime xn. The formula is written in this box. We call it the assignment box. This is where a task is performed and is rectangular form. It represents the general processing operation, usually data movement instructions. Only one flow line should come from or out of the process symbol. So this line should have only one line joining this assignment box to the other. Then we have what we call decision box, or decision symbol, or can say decision statement. In this statement, a decision has to be made in order to determine which direction to take. Decision is very important as you make a program, because if you don't make proper decisions as you make a program, then you have to fail whatever task you are given. So a decision is, we use the symbol which is rhombus, and there are two decisions to make, either yes or no, or true or false. But we use yes or no, not true or false, but these are the two synonymous words. Yes, true. No, false, because now they can say, is n greater than 6? Then that is a question mark. Now you have to decide, is the n, the value of n you have, more than 6? If it is more than 6, then you say true, that is yes. If it is less than 6, then you know, you say false, then you continue with the program. It has one inlet, and two outlets, one with a yes, another one with a no. So these are the shapes that we use to form a flowchart, and you must know that this decision box is very important in flowcharts. Therefore, to make a recap, we said we have flow lines which join symbols from one symbol to another. If we want to start the program must have the starting and the end point, that is oval shape. We must take the reading, we have to read values, say read A, or we have to print, because we must have the set of solutions from the flowchart or from the program that we have. Then the assignment, the program must be having a task, and this task, in order to have it completed, we have to make proper decisions which are put in this diamond box, and therefore you come up with a proper flowchart, as we shall see how to draw them.